Question 5a, they want to know, is the function here, well, this is only a quick sketch of it, is it injective or not? Well, injective means a one-to-one mapping, so we need to look at the outputs and see if any output, any y value, has two x values, and look, even just there and there. So another way to explain that is to say, okay, it doesn't, it fails the horizontal line test. Okay, just there, from there on, it seems to fail the horizontal line test. But I need to explain that properly and mathematically. You can have the idea in your head about the injection, that every y value wants maximum one injection. So there, that y value has two, but you're not going to explain it like that in the exam. That's how you'd explain it to yourself. You're going to say it's a one-to-one mapping and it fails that idea. Part B then, it says find f dash of x, so it wants me to differentiate this. So I'm going to use the product rule to do it. U is x squared and v is ln x. So the product rule says u times dv dx. Now if you differentiate ln x, you go to your log tables, you end up with 1 all over x, plus v times du dx, which is 2x. And I just need to clean this up, and I end up with x plus, because they simplify, 2x times ln x. Okay, so that's f dash of x. Could also write it, take the x out in common and write it as 1 plus 2 ln x. They haven't asked for it in any particular format, so either of those would give you full marks there. Part C, they want me to find the turning points, find the coordinates of the local minimum point of the graph in terms of E. Well, what do you know about the local maximum or minimum? You know the slope is 0. So I'm just after finding out the formula for slope there. X plus 2x bracket ln x equals 0. I'm going to solve this equation. I'm going to take the x out in common. That's 1 plus 2 ln x is equal to 0. And I'm going to let each factor here equal to 0 as I normally would. Now, it says that x has to be greater than 0 because we're dealing with, in the question, right back at the very start, they said that x has to be greater than 0. So, in that situation here, that's not a possible solution. And so I'm continuing on with this side. I end up with 2 ln x is equal to minus 1. Ln x is equal to minus a half. And then I can go into log form, or come out of log format here. So e to the power of minus a half is equal to x. And that's the same as, you know, I could rewrite that as 1 all over root e, either way, is equal to x. So that's the x coordinate. If I want the y coordinate, I need to go back to my original equation. My original equation says f of x is equal to x squared ln x, and if I put that in, I'll find out the y value. So far I have 1 all over root e is the part of the minimum turning point. And I need to just put this in here. So I have 1 all over root e to be squared times ln 1 all over root e. And if I clean that up, I'll end up with minus 1 all over 2e. So I'll just square this, it becomes 1 all over e. This I can clean up a little bit using indices and working with it then with the logs. So I would probably clean this up by going ln of e to the power of minus a half, which I can bring in front. That's minus a half ln e. That's log e in the base e, which is just 1, which leaves me with the half. So I end up with 1 all over e times minus a half, which is where I got this out of, just in case when you clean it up. That's where I got this out of. So my other part of my point is minus 1 over 2e. Now I might want to prove that that is the local minimum and not the local maximum. So if I wanted to do that, I'd have to get my second differentiation. So when I get my second differentiation, now I hope you'll be able to work out your second differentiation by, so if that is x plus 2x ln x, my second differentiation, I'll just differentiate this, it'll turn to 1, and I'm going to use the product rule to differentiate this. Now you should definitely be able to do that, and you'll end up with 2x times 1 all over x. So that's u times dv dx plus 2 times ln x v times du dx, and you just clean that up and you end up with 3 plus 2 ln x. Now, the reason I'm doing my second differentiation here is because I want to show that it's a local minimum. So when I sub in my x value, which I have found out to be 1 all over root e, here, I sub it in and I end up with the answer 2. So just sub that in, work it out, you end up with the answer 2, which is greater than 0, which shows it is a local minimum at the point 1 all over root e, comma, minus 1 over 2e.